In this video, I will be telling you how you should be approaching a technical question, right? So let's say you go for the interview and there's a table and there's the interviewer and there's you, right? And then let's say you are given a question like this, right? Then they give you a piece of paper and then they ask you to solve this, or they ask you to write the code, right? So whenever this type of a question is given, so these are technical questions, right? How do you check if an array is symmetric? So this is a technical question. How should you be approaching this question? So before going into question, I want you to understand these things. So the first thing is, let's say this is the timeline, right? This is the time at which you are given this question, and what typically happens is that you try to read the question and you're thinking how to solve this question in your mind, right? So that's how we are used to do. So even like we are more familiar with exams, right? In an exam, what happens is you are given a paper in which you can find the questions, and you are given another paper to answer. You read the question, and in your mind you are deciding, or you are thinking how to solve it, and then after you think, you write the answer, right? That's what we have been doing throughout our life. But if we are going to do the same thing here, it's not gonna work, because let's say so the interviewer does not have the whole day for you, right? You would be getting a limited amount of time, like maybe 30 minutes or something like that. So in that 30 minutes, not only for this particular question, right? Let's say the whole time for your interview is 30 minutes, and they would be asking a lot of things like general things, behavioral things, and then when they come to technical part, you would not even have 30 minutes. So you have to get the most out of the time. So if you, whenever the question is given to you, if you just keep looking at the question and try to solve it in your mind, and then let's say you think for like 3 minutes, like 3 or let's say 2 minutes. So throughout this time you are like dead silent, you are not talking anything. So when that happens, this interviewer, he does not know what's going on in your mind, right? So in exams, that's what we do. We think and we write. At the end, the lecturer will mark the paper and decide your point. But here it's not the case, right? Here, let's say you think for 2 minutes. If you really understood this question, and then if you can give the correct answer, then that's okay. But most of the time you are more likely to not be able to solve the question fully, right? Typically, like if it is a very simple question, it could be possible, but sometimes it's not. So the first thing that you should remember is never do this, right? You are not gonna be silent for like not even for like 10-15 seconds, right? So that's the first rule. Don't be silent. And the second rule is, whenever you sit here, try to play a role of a teacher. right? So whenever, let's say this is a teacher, right, and this is the whiteboard or blackboard, and there's a equation. Right? So have you ever seen a teacher who looks at the board and think for like 1-2 minutes and then completely finish the problem and get the answer and draw 2 lines like this and then start explaining? No, right? That's not what teachers do. They start talking right when they see the question, right? They start from here and they explain each of these. It's not that they have memorized the steps, right? What they are doing is they are explaining what is going in their mind in real time. So that's what you should be doing. Whenever you go here, right from the beginning, right when you read the question, even read this out loud. I mean, if this is given in a paper, read it out loud. If it is coming verbally from the interviewer, just repeat it until you get the idea, right? Then so now you are a teacher, right? So if you are a teacher, how would you approach this question? I mean, when you read the question, it might not make much sense, but what you should do is, I mean, if this is not given in a paper, I think it's better to just write the question in the paper so you can focus it more. So the first thing is you will do is find the keywords, right? So I forgot to mention another thing. So when you're solving a question, so this is something that Asita sir said. So let's say to solve this particular question, there are different steps, right? There are things that you should know. So they are like a stack. So you should first know this, and then it helps you to go to the next step, and finally you can solve the problem, right? So what typically tend to happen is that when you see the problem, you are more focused on the last step, right? How do you check if an array is symmetry? So this could be the last thing, right? This is the final output. But to get there, you should be following these steps. What happens here in this silent phase is that you go through this in your mind, right? For example, so first you should know what an array is, right? So let's see, this is something related to array, and then something related to symmetry, and so on, right? So these things you are thinking, because why you are doing like that? Because that's what you have practiced in exams. You read the question and try to think in your mind. In exams you are not talking, right? It's like dead silent. So the thing is, you should not be silent, and you should be explaining each and everything. And if you kept silent and let's say at this phase you could not even think how to do it properly, right? You know everything up to here, but you were worrying about this part, the last output. But what does this imply to the interviewer? For the interviewer, you were silent for 3 minutes and then you could not even do the problem, right? So it's like a total failure. The interior things, you do not even know what an array is, because you did not even tell anything about array. Okay. So I mentioned few things, right? First thing is, you should not be silent every time. So when your mind works, try to verbalize that, right? So that's the first thing. And then think of yourself as a teacher, right? Teacher does not look at the problem and try to solve it and get the answer, right? So this is what a student do. So teacher always go step by step until they reach the answer and explain every intermediate step, right? They explain the thinking process. The step that you are doing or writing might be wrong, but the thinking pattern is what the most important thing. Okay, so now what I'm gonna do is, I'm going to like demonstrate how you could do that. Right now, until now, what I told is what we should be doing, right? So now I'm going to do it. So the rules are, I'm not going to be silent, and I'm going to act like a teacher, and I'm going to explain every intermediate step. I'm not worrying about solving this particular question, right? This question, it's already solved, right? You solving this does not change anything in the world, right? So the interviewer, he knows the answer, right? He knows the answer. He knows this is already implemented. So he is not giving you this question to like fully solve it and make some effect to the world. That's not his intention. His intention is to see how you process, how you think. So therefore, do not worry about perfectly solving the question. Try to showcase how you think, right? So now I'm going to do this question as the way I explain. Right? So now I am given this question and I'm going to start answering. So I see the question, I read it. How do you check if an array is symmetric? Right? So here we are talking about arrays, and we want to check whether it is symmetric, right? So the first thing I would do is, so if you are writing an algorithm, it's better to start with a function, right? So I'm going to write a function like if symmetric, and then what would be the input? Input would be an array, right? So at this point, you should ask, in this array, which type of elements are we going to find, right? So I mean, you might just simply write int array arr, right? So this will come naturally, but in the question, it's just mentioning array, right? I mean, if you are doing like a HackerRank or LeetCode problem, they will be giving you every single detail about the question, what are the types and what are the constraints. They will be given all of these. But in an interview, they will not be given everything, right? They just give the high level idea of the question. So they measure your thinking ability by the questions you ask. So when you are given a vague question like this, you should ask questions and get clarified what they are really expecting from you, right? That's also a skill. So first you should ask, what sort of elements are there in this array? So typically it could be integer. So if there's, say, another thing or string, you put string here, str, no, string, right? In Java, if I'm coding in Java, it would be string capital S. Right? So this, what would this be returning? So how do you check if an array is symmetric? So we get the array, and inside the algorithm it will figure out whether it's symmetric or not, and then we should return whether it's symmetric or not, right? So what should be the return type? It should be Boolean, right? So right now I'm just doing what I would do in the interview itself, right? Don't think I'm explaining this because I want to teach to you. No, I'm just doing what I would do in the interview itself, right? So so until this point, right? So what I did was I read the question and think how should the function work, right? I only thought of inputs, outputs, and I just gave a name to the function, and then I also asked a question from the interviewer, right? So I'm not silent. From the time at which I got the question, I was asking and explaining things. I was never silent for even 10 seconds, right? Okay, so until this point I did a lot of things even without knowing how to solve the question, right? Whenever you got the question, do not immediately think of the solution, right? Solution is here, but to get to the solution you should go through each of these steps, and you should show the interviewer that you know these things. So if you show that you know these things, it doesn't matter whether you can solve it perfectly, right? So without even knowing how to solve the problem, I did a lot of things that are plus points for me. So that's how you should approach. And then I would start the implementation. So we are talking about arrays, right? Arrays, and you want to check whether they are symmetric. So I might not know how to do it right off the bat, but I can I can use examples and see what is really happening here. Like we have an array, so in an array we can have numbers, right? So this is an integer array. Let's think of this as an integer array. It could be a string array or something else as well. Integers are easy, so let's say we have 1 2 5, right? Then we want to check whether it's symmetric. So what would symmetric mean? So symmetric means, so if let's say we have a shape, so if we have a shape like this, if it is symmetric, we should have something like this, right? So it's the same in array as well. So in an array you can divide it from the middle, and if it is symmetric you would see the reflection of this part in this part, right? So again, I'm not doing this to make sure that you understand. I'm just telling this to the interviewer himself, right? So when you're explaining, do like this. So if this is symmetric, that means you're gonna have the reflection 5 2 1. So this is we can get this form when we have even number of elements, right? If we had like odd number of elements, we would have something like this, where we cannot really separate from the middle. In the middle also we would have an element, right? So these are the two main types of cases we can have. And then if we consider something that is not symmetric, so this is not symmetric. So if we get the middle and compare, so 2 is not here, right? So this is not the reflection. So now we know what symmetric mean, right? So we are coming from here, right? We are covering this lower level stuff. So we talked about array, and we talked about being symmetric. We saw some examples, right? Now we are going to think how we can find whether this is symmetric or not, right? So if you look at an example where the array is symmetric, you can notice that if this is symmetric, you can find this element here as well, right? Same element. The next element is same as this, and if you have odd number of elements, you would end up here. I mean, we do not have anything to compare with that. But if you are having even number of elements, then you compare this to this. Okay, it is same, therefore we can move on, and you go to next one. It's the same. Okay, it's the same. Okay, and now it's over, right? And if you, let's say this was 3, right? How would you search? You go to this element and this element. Now we are accessing these two elements simultaneously, right? We were comparing two elements at each step, right? So we compare this to this, and then we compare this to this. So that means we might need some pointers to access these elements, right? So pointer is nothing but just an index, a variable that holds the index. So we can have like a pointer called left. So this just stores the index that we are currently accessing, and we need another one as well. We have two pointers, and we are accessing the elements, and we are comparing them. One is equal to 1, or left one is equal to right. Then what should we do? We go to the next one. So we update the left pointer by 1, and right pointer we reduce it by 1, and then we compare. So now we have a mismatch. Left point is not equal to right pointer. Then that means the array is not symmetric. So we do not have to continue further. Once if we find mismatching elements, then we can simply return false, because it is not symmetric, right? If it is symmetric, we will not be finding unmatching or mismatching elements. So if we found mismatching elements, then we can return. Otherwise, so when you see this from a high level, you should feel that we need a loop to iterate over this array, right? You would be having left and right pointers, and then you would need to iterate, move one step by one step. This point increases, this pointer decreases. So we need a loop, and so inside this implementation we need a loop. Before the loop, what should we do? Before the loop, we should have the pointers. Before the loop, we should have pointers. So the left one would be starting from the 0, right? So int left, that would be starting from 0, and int right. So what should be the value, starting value of the right pointer? So the right pointer points to the last element of the array. So how could we know the last index? Last index is actually, we can know the length of this array, right? If we take ar dot length, we get the size. But since this is starting from 0, the indexing start from 0, our last index should be arr dot length minus 1. These are the two starting points for our pointers, and then we should go inside a loop, right? So we can use a while loop. So inside this while loop, what should we be doing? I mean, so there would be a condition here. I'm not going to worry about the condition right now, right? So inside the loop, what we do is we compare the left element and the right element, right? So we have the pointers left and right. We can use these pointers to access the element in the array, right? So if the left element and right element are not equal, then we can immediately return false, right? Because it is not symmetric. There's no point moving forward or continuing the search. So if ARR left not equal ARR right, what does that mean? That means this is no longer symmetric. So we can simply return false, right? Then what should we do? So this is a loop. In the loop, we should move step by step. The left pointer should move right pointer should move left. So left pointer, we should increase it, and the right pointer, we should decrease it. So you can do it in different ways. So you can do it like this: right minus minus, right? Or you can also do it here as well. You can put left plus plus here, right minus minus here. That is the same effect, but this makes more sense. So now we are moving, and when should we stop? I mean, if we, according to the condition we write here, the behavior of the loop is decided, right? I mean, if we find two mismatching elements, then we do not have to worry about the condition here. We can simply return, because we are gonna return here when we find out those two mismatching elements. But what if we could not find any mismatching elements? That means if the array is symmetric, we would never reach this block, right? Then how are we going to terminate our while loop? So then to understand that, we should see how the pointers are moving. So earlier I saw that the behavior depends on how many elements we have, whether it's odd or even. Let's say we have if we have odd number of elements, you start here and left here, right here, and then you increment left, right. So at this state, can we perform this operation? We can perform this, right? We can array left points to this, array right also point to same thing, and this would not do any harm, and we can continue the loop. And once we get out of this block, we are not even going inside this block because they are equal. left and right pointing to the same element, then we increase left and decrease right. So next time, for the next iteration, left would come here, right would be here. Okay. Now we no longer have to continue the loop, right? If this happens, that means the array is symmetric, because we did not return here, and now the left is greater than right. That means we have searched all the elements. So that is the case where we should terminate the loop. So if we should terminate the loop when left is greater than r, when should we run the loop? So here we are writing the condition for running the loop, right? So we should terminate the loop when left is greater than r. We should run the loop as long as left is smaller than or equal r. Okay. So before deciding the actual condition, we should also check whether that is applicable for this case as well, because we had two cases, right? So in this case, we would have r, l here, and then next r comes here, l comes here, and next l goes here, r goes here. So in this case also we can find it should be l here, r here, and l goes, we increase l, decrease r, and then in the next iteration l goes here, r goes here. So now again we find l is greater than r. So the condition that we considered, it is applicable for both cases. So now we can use that condition. So once if this loop ends without returning, right? If this loop ends without returning, that means we looked at all the elements in the array. We looked at all the elements and we could not find any two elements that are mismatching, right? That means the array is symmetric. So once if you come out of the loop here, then it is guaranteed that the array is symmetric, so we can return true, right? So that's how you approach the question and tell each and every step that you perform. So let me give me a second to verify whether I have written this correctly. I had the answer somewhere. Okay, so in the answer, the condition that I have used is left less than r. So I in the answer it is like this. So you might have seen that I have done many mistakes, right? So here I am defining L, here it's left. I mean, that could happen, but don't worry about that. It's better if you can avoid these mistakes, but they are forgivable, right? So we are not doing this on an IDE. So let's think whether we should consider equality, right? So okay, so here's the thing. I mean, this is also correct and this is also correct. Why? Because it's like this. So when would this L equals R condition occur? It occurs when we have odd number of elements, right? That's where we get R and L equals. So at this state we do not have to like perform this round or perform this step, because if they are pointing to the same thing, then there's no use of checking this condition whether they are equal or not. So then we can simply return at this stage as well, right? So that's why we can remove that equality here and strictly find whether left is smaller than right. So yeah, so I think this should help you to sort of talk when you are solving the question, right? Don't stay silent. Try to express what's going on in your mind, everything. Do not think quietly, right? Thank you.